Hello? Hello? Fine? That's good. Hi, Rohit Singh. Right. So there is an audio issue. Please confirm, are you all able to hear me? Yes, you are all able to hear me. Please confirm. Yes. Rohit Singh and Tilak Raj, let us continue with our session, right? Okay. So moving ahead, in Infinity Lane, Google app, you can see Infinity Lane app where you are going to see the live classes, mock test and create your own test and 24 by doubt resolution sessions. When these are there, these are completely free of cost, my dear children. Create your own test. This is the area where you can access it as a free and 24 by doubt resolution sessions, where if you are preparing for any topic, if you have a kind of difficulty in that, you can just open this and create your own test directly, you can get it. And where one more important thing, we have All India Test Series NEET 2025, and this All India Test Series NEET 2025 series is started by Infinity Line. It is a scientifically designed assessment platform. In that you are going to have 34 full syllabus test and 14 grand test, 20 mock test, and your performance is going to be benchmarked with Sri Chaitanya students against India's best, so that you will be having a proper assessment on what you are doing and how you are doing. So detailed video solutions are each and every test will be there, and it was around 6,000 rupees. Now it is coming for 1,200 rupees, 80% सस्ता मिलेगा आपको. So when you apply coupon code YT80, ताकि आपको मिलेगा 80% डिस्काउंट. प्लीज एंटर द कूपन कोड इन द डिस्क्रिप्शन बॉक्स इन द pinned messages. The link is given. You just click it once and you can enjoy it. Okay, anyways, our task is done and promotions are over. Now let us talk about the topics that we are going to discuss in the chemical bonding. Chemical bonding is going to be the most important topic. It is connected to overall inorganic chemistry and also overall organic chemistry. Once you are very good at chemical bonding, you can handle most of the part of the chemistry. So let's talk about the topics that you cover here. This is Lewis electrovalent theory and ionic bond, covalent bond, and VSEPR theory and valence bond theory, hybridization, molecular orbital theory, hydrogen bonding, and also bond parameters. So this is the main course of this. So directly from this topic you are going to get one question, indirectly you are going to get two questions from this. So on an average 2 questions will be yours in the NEET examination. For that 8 marks will be in your pocket at the end of the session. Are you ready for that? So most probably you are going to get a question even from here, VSEPR theory and hybridization, molecular orbital theory and bond parameters and hydrogen bonding. So how hydrogen bonding is connected? Yes, it is connected in the deciding the stability and boiling point, other things in the organic chemistry as well. So it is totally connected with the entire chemistry. Let us start without any delay. So please confirm, Rohit and Tilak Raj, is my voice is audible? Right. That's very good. Let's start without any delay. Yeah, hydrocarbon part 3 कब आएगा? अगले हफ्ते में आएगा. Ved, I hope you enjoyed hydrocarbon alkane and alkene we discussed, right? And arenes also will discuss in that. Hi Vishnu, Sai Lila Vishnu. It's not louder? Okay, you check your internet connection, because so far we technical team is working on this only, so our side it is okay. Okay, anyways, let's start about Koshal-Lewis theory, formation of cleavage of chemical bonding. So I don't want to spend much time over very fundamental things and scratch level things. Okay, we are in NEET examination preparation, time भी बहुत कम है, so ज़्यादा से ज़्यादा कम टाइम में कवर करने का कोशिश कर रहा हूँ. So attractive force, when two atoms join together, so there should be an attractive forces and a repulsion forces. So when these attraction forces are greater than repulsion forces, you are going to get an appropriate bond between these two. Experimentally, it is found that the magnitude of the new attractive forces more than the new repulsion forces, ताकि इसका bond चलना है. And as a result, two atoms approach each other and the potential energy decreases. Why do elements participate in bonding? So it all depends upon the stability. So stability of any system inversely proportional to energy. So when two atoms come and join together, their overall potential energy decreases, so that stability is going to be increased. So we have various types of bonds that we are going to join immediately, since the energy get released. So when the bond is formed, energy is released. Like you see, hydrogen atom and hydrogen atom with high energy in the gaseous state, when they are combined, so it is going to form the lowest possible energy state of the molecular level, so that 535.8 kilojoules of kilojoule per mole energy is released. So mind it, when the bond is formed, energy is released. When the bond is broken or cleaved, energy is required. That is a fundamental aspect you need to know. Okay, so stay tuned with a lot of patience. I am going to give you very good amount of content and with very good techniques, so that when you want to prepare for the entire chemical bonding, it takes at least 2 to 3 days. In the 2 hours duration, I just want to give you the session by the entire verse. Okay, so let's talk about the electrons present in the outermost shell is called valence electrons. So in the periodic table, you can see, I wanted to say here it is all about the octet rule. Okay, so these are the elements in the periodic table. In these elements, you can see helium, neon, argon, krypton, xenon and radon. These elements are called noble gases. They have 8 electrons in this outermost shell. Of course, and it is just 2 electrons. So presence of 8 electrons makes it stable. So they are called as octet. Whereas presence of 2 electrons, it is stable. This is what is called as a duplet. Of course, octet and duplet, octet is stable and duplet is stable. Among this octet and duplet, which is more stable, you mention it. Among octet and duplet, which is more stable, you mention it. You only mention it. Yeah, I'm just watching the start box. Want to say, yes, duplet is more stable as compared to octet. So मैं क्या बोलना चाहता हूँ here, except noble gases, so all the elements in the periodic table has less than octet. Okay, less than 8 electrons. They always try to acquire 8 electrons. ये 8 electron मिलने के लिए हमेशा कोशिश करता हूँ. कैसे, इलेक्ट्रॉन दे सकते हैं, इलेक्ट्रॉन ले सकते हैं, इलेक्ट्रॉन शेयर भी कर सकते हैं. So by sharing the electrons, they are going to form a covalent bond, and by giving completely loss or completely gain of the electron, they are going to form an ionic bond. So let's talk about these various types of bonds, including ionic bond, covalent bond, and a dative bond is also there. In that comes sometimes we have various theories in that. Everything we will discuss it. Okay, so I just want to say, yeah, this is all about octet, and I already explained. I don't want to give some much granular level of discussion at this basics, because everybody knows it. Directly we will jump into the subject. So let's talk about the ionic bond. Ionic bond is when a cation is taken and anion is taken, दोनों के बीच में electrostatic force of attractions, the attraction forces between the cation and anion is called as electrovalent bond or ionic bond. So let's see, the ionic bond is formed by the transfer, complete transfer of electrons from a metal to non-metal, donor to acceptor, or electropositive element to the electronegative element between two systems. Okay, so the electronegativities of the element A and B is the deciding factor to say a compound to be ionic or partially ionic or covalent. So let's say if element A has very low electronegativity and B has very high electronegativity, there will be a transfer of electron between from here to here. So it form a cation and it is going to form anion. Okay, so there will be an ionic bond. If there is no much gap between these two, very high electronegativities are there, a non-metal and a non-metal, so there will be a sharing of pair of electrons that form the covalent bond, and low to low, and they readily lose the electrons, they are going to form the metallic bond. I just want to say, if the electronegative difference is greater than 1.7 ताकि इसका इलेक्ट्रोवैलेंट बॉन्ड होना की संभावना है. इलेक्ट्रोवैलेंट बॉन्ड का मतलब आयोनिक बॉन्ड है. If it is difference in electronegativity is less than 1.7, it is going to be covalent bond. Covalent bond. Okay, so this is the difference. Oh no, if the electronegativity difference is 1.7, इसका क्या चीज है? Okay, Sai Leela, you tell me, Ved, you tell me, Rohit and Tilakraj, it is an interactive session, it is not a radio telecast session. I want you to be participate in discussion between you and me. Okay, so it is going to be polar covalent bond. So what is the meaning of polar covalent bond है? Covalent bond है लेकिन उसमें charges भी थोड़ा बहुत रहता है. Okay, let's see in detail about the ionic bond and how it is formed and everything. Okay, right? That's good. Now let's see, the difference in the values of the electronegativity should be greater than 1.7. Atoms of element with low ionization energy to form has a tendency to form cations and vice versa. Let's see what are the favorable conditions for the formation of ionic bond, and this is the part where you are going to get NEET probable question. So what is the condition? An element should lose electron and forms a cation. So I want to say any factor that lose electron is going to be the least comes under this. So based on Rohit, and let's see first formation of a cation देखना चाहता हूँ and formation of anion बाद में देखना है. So for that generally the metal atoms has a tendency to lose electrons. So for that the elements with lowest possible ionization energy can lose electrons so easily they can form cations. So I wanted to say low ionization energy. You just see ionization energy order. Okay, lithium, sodium, potassium, rubidium and cesium. So ionization energy is going to be like this. So least possible ionization energy has a greatest possibility to lose electron. So that ease of formation, it is going to be lithium plus sodium plus potassium plus rubidium plus and cesium plus, so that it is being having a lowest possible ionization energy has a greatest tendency to form cation. So this is the logic when you solve the questions in the JEE exams, NEET examination idea students. Okay. Now let's see some more things over here. And low charge on the ion, this is very very important. So the one which has a low charge on it, let's say talking about sodium plus, let's take magnesium 2 plus, let's take aluminum 3 plus. So to form this, just IE1 फर्स्ट आयनाइजेशन एनर्जी इस्तेमाल करना काफ़ी है, लेकिन ये फॉर्म करने के लिए फर्स्ट आयनाइजेशन एनर्जी, सेकेंड आयनाइजेशन एनर्जी भी इस्तेमाल करना है। लेकिन ये एल्यूमिनियम 3 प्लस फॉर्म करने के लिए फर्स्ट आयनाइजेशन एनर्जी, सेकेंड आयनाइजेशन एनर्जी, थर्ड आयनाइजेशन एनर्जी तीनों भी इस्तेमाल करना। सो सम ऑफ दिस IE1, IE2, IE3 एनर्जेटिकली बहुत एक्सपेंसिव प्रोसेस है। So that formation of this aluminum 3 plus is too expensive, इसी का कारण इसका मिलेगा। So that it is going to be, इसका कम से कम होगा, ये कम से कम होगा। Understand ease of formation. I want to say the cation must have the low positive charge on it, can be easily formed. Are you getting or not, Rohit? And so the same thing is given. Magnitude of the cation charge is इनवर्सली प्रोपोर्शनल टू आयनिक नेचर, दैट फाजान रूल में फिर मिलेंगे ये पॉइंट पकड़ने के लिए, है ना। जस्ट अ मिनट। Right. So let's see large atomic size. So ionization energy is inversely proportional to the atomic size. So the one with the larger atomic size will have the lowest possible ionization energy, so that it is going to form easily. So the metal atom must have the large atomic radius as the size of the atom increases. So that size is going to be lithium plus, sodium plus, potassium plus, rubidium size, and cesium is the largest one. So cesium can form its cation easily, so that you are going to see the ease of formation is going to be lithium plus is difficult, sodium plus is difficult, potassium plus is difficult, rubidium plus is difficult, cesium plus. Are you getting or not? Any doubt, Rohit? Sai Leela, expecting you to post some questions. Expecting you to post some questions. Okay, now cations with inert gas configuration. Here this is a very important point. So what is inert gas configuration? 8 electrons in the outermost shell is called as inert gas configuration. 18 electrons in the outermost shell is called pseudo inert gas configuration. Pseudo inert gas configuration. Could you tell me some example with pseudo inert gas configuration? Anybody? One thing in the chart box. Children, one thing in the chart box. It is going to be high. Akhir Media, Rohit Sharma. You can see zinc 2 plus. It is going to have 1s2, 2s2, 2p6, 3s2, 3p6, okay, 3d10 and 4s0. So you can see here 18 electrons are there. It is a pseudo inert gas configuration. Agree? So whereas magnesium 2 plus is going to have only 1s2, 2s2, 2p6, इसका सिर्फ 8 electrons है noble gas configuration. मैं क्या बोलना चाहता हूँ here, when an cation with noble gas configuration can be easily formed as compared to the cation with pseudo noble gas configuration. Agree? Right. The period current or still, which period in which term you want to say? Yeah, I want to say S block elements always have noble gas configuration like alkali metal and alkali earth metal, while you see D block elements generally have the pseudo noble gas configuration. They have the bit covalent properties, है ना? And you can see here formation of anion. फिलहाल हम क्या देखें? We have seen only cation का है, अभी देखना चाहता हूँ the anion. So कैसे anion कैसे form करता हूँ? कैसे form करता हूँ? So by gaining of electron, any factor that favorable condition to accept the electron, so like a high electron affinity, has element with high electron affinity has a great tendency to accept an electrons, they form anions easily. Or actually is a low charge on the anion with low charge on it can be easily formed because energetically it is less expensive, so that formation of F minus is easier as compared to O2 minus is easier as compared to N3 minus. Okay, it is a nitride ion, oxide ion and fluoride ion, right? Akhir, okay, Sailila and Ved and Rohit Singh. Okay, let's talk about and small atomic size of the non-metal. The non-metal with a smaller size has a great tendency to accept the electron and they can form anion so easily. Okay, and anions with inert gas configuration का anions इतना काफ़ी important नहीं है, but लेकिन आप देख सकते हैं, are you getting or not? Now you can see and the polarization of Fajan's rule बहुत काफ़ी important है, and here you guys will have a lot of confusion. Polarization, actually what happened, this is a cation and this is an anion. Okay, so the anion चांद के जैसे दिखते हैं. Okay, so this is your anion, so there will be attraction force between the cation and anion. Hi Shubham, yes. Now this cation being attracting the anion, so that ताकि इसका शेप जो है डिफॉर्म हो चुका. So this process is called as a polarization. So the ability of cation to polarize in nearby anion is called polarization power. Polarization power किसका property है? Polarization power cation का property है. And polarizability इसका anion property है शुभम. And polarization is directly proportional to the covalent character. जिस compound में polarization process ज़्यादा होता है उसका कोवलेंट प्रॉपर्टीज भी ज़्यादा होता है. सो आयोनिक प्रॉपर्टीज का अलग होता है, कोवलेंट प्रॉपर्टीज का अलग होता है. इसका क्या फ़र्क पड़ता है देखना. सो आई जस्ट वांट टू से द फाजान रूल फैक्टर्स अफेक्टिंग द पोलराइजेशन, and you can say polarization is inversely proportional to size of the cation. You can see beryllium chloride, magnesium chloride, calcium chloride, strontium chloride, barium chloride, उसमें क्लोरीन कांस्टेंट है, लेकिन बेरिलियम टू बेरियम साइज बढ़ते जाता है. सो एज दिस साइज इज इंक्रीज्ड, ओके, कोवेलेंट कैरेक्टर डिक्रीजेस, आयनिक कैरेक्टर इंक्रीजेस. इसमें सबसे ये वाला मोर कोवेलेंट होगा, उसमें लेस कोवेलेंट होगा, ताकि इसका मोर आयोनिक भी बोल सकते हैं. सो मोर आयोनिक is barium chloride. So the down the group what happens, the solubility increases. समझ में आ रही क्या? समझ में आ रही क्या? Clear? Now similarly, greatest polarizing power of beryllium shows its maximum covalent character. So that sodium, magnesium, aluminum, silicon, so covalent character is directly proportional to Shubham, it is about charge. So polarization is directly proportional to charge. Polarization is directly proportional to charge. So जिसका चार्ज ज़्यादा है उसमें polarizing power भी ज़्यादा होना चाहिए. So that sodium, magnesium, aluminum, silicon. So इसका चार्ज ज़्यादा है, polarization ज़्यादा है, ये कोवलेंट ज़्यादा होता है. नाउ इट इज़ गोइंग टू बी मोर आयोनिक, सोडियम क्लोराइड होगा, लेस आयोनिक, सिलिकॉन टेट्रा क्लोराइड होगा. नाउ वी कैन सी वेरियस थिंग्स. द feasibility of having some covalent character can be predicted by using Fajan rule. That is the basic application of the Fajan rule. ठीक है? And the compound is more likely to be covalent. This is a super awesome slide that can give you a lot of information. Charge, whenever charge comes na, it could be positive charge भी, it could be negative charge. दोनों के भी ये charge formula इस्तेमाल कर सकते हैं. शुभम, fine. Now we can see cation, small cation or high charge is highly polarizing and attracts electrons in the anion. हाँ, and anion के लिए large size, high charge, it is highly polarizable and it will be easy to be distorted. Shape is going to be distorted, it is going to be more covalent. I wanted to say here, big cation and small anion, more ionic. समझे? Clear? And this trick can help you. A small cation and a big anion, it is going to be more covalent, provided the charge is same, magnitude of the charge is same. So use this trick everybody, and can use this trick for saying relatively आयोनिक और रिलेटिवली कोवलेंट. समझ में आ रहा है क्या? अगर कुछ डाउट है ना तो आप पूछना सीधा. शुभम, रोहित, वेद, साई लीला एंड आखिर, कम ऑन जल्दी. Yeah. Now let's talk about some questions. I just want to show you here some questions. मस्त आहे slide. Okay. मस्ट बी मार्क भी मिलेगा आपको, मस्ट बी मार्क भी, ठीक है। नाउ लेट्स टॉक अबाउट हियर size of anion, size of anion. If the size of anion increases for given cation, the covalent character increases and the nature of polarization is directly proportional to size of anion. Okay, so calcium fluoride, calcium chloride, calcium bromide, calcium iodide, calcium यहाँ पर constant देख रहे हैं, लेकिन फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन का साइज बढ़ते जाए. So as the size is increased, so what happened? Covalent character increases because ionic character decreases here. Let us talk about, so this is the example can give you emphasis on size of anion. I just want to give you और एक example, उसमें charge on cation and anion भी देखना है. शुभम आपका doubt है. So polarization is directly proportional to charge on the cation or anion. Okay, दोनों में possibility है. Right now सोडियम क्लोराइड, मैग्नीशियम क्लोराइड, अल्यूमिनियम क्लोराइड, सिलिकॉन टेट्राक्लोराइड, उसमें सोडियम क्लोराइड का +1 है, +2 है, +3 है, +4, इसके चार्ज ज़्यादा से ज़्यादा है. ओके, सो व्हाट हैपन इसमें शुभम, राइट, इट इज गोइंग टू बी मोर कोवलेंट, चार्ज ऑन कैटायन इंक्रीजेस, कोवलेंट कैरेक्टर इंक्रीजेस and ionic character decreases. Whenever ionic character is there, it has high melting point. So ionic character decreases means more covalent, so that melting point भी कम होना चाहिए, so that physical properties in the chemistry you can handle it. ठीक है? And you can see charge on anion increases, polarizability increases, and covalent character increases, and melting point decreases. So how organized it is given? Directly you can use this systematic logic and you can create a very good scoring points in your NEET examination. I can guarantee you this. Agree? Just session started 35 minutes ago. Very good number of viewers are there and really enjoying these sessions and this content. है ना? Is everything is fine? Dear students, is everything is fine? Can you all able to hear me, see me? Can you all able to hear me, see me? Confirm? Yeah, Ved, wonderful, wonderful. That's good. So next one, electron configuration of the cation भी बहुत important चीज है यहाँ पर. Okay. Now you can see polarization capacity of cation is more for pseudo inert gas configuration जिसमें 18 electrons वाला है. And you can see with, and you can see copper chloride and sodium chloride, it is more ionic and it is going to be more covalent. So that more ionic melting point iska value, don't by heart this value, but you can see the value over here, it is 1800, less, more covalent, less melting point, because copper का covalent nature ज़्यादा है pseudo inert configuration का हिसाब से. ठीक है? ठीक है? Right. Now here we can see copper 2+, so Z effective nuclear charge plays a crucial role in deciding this covalent nature and ionic nature. So everybody knows about the ionic and covalent bond, but the gap between these two is about Fajan rule. Definitely based on the Fajan rule, definitely you are going to get one question. है ना? With next, which of the following? So these 4 questions are there in a single slide. Let us carefully analyze these 4. Okay, which is most ionic? Apply Fajan rule. Sodium fluoride, okay, sodium oxide, sodium nitride, and all are same. When you talk about sodium fluoride -1, sodium is constant. Take the variable, and it is going to be -2. And it is going to be -3. जिस आयन में ज़्यादा चार्ज है वो आयन का पोलराइजेशन ज़्यादा होगा, सो दैट इट इज़ मोर कोवलेंट, इट इज़ गोइंग टू बी मोर आयोनिक. हाँ, अनुष्का राय, गुड आफ्टरनून, कैसे हो आप? Okay, waiting for my dear students, and Tribeni Roy is also there, should be in the class with Shubham. Come on, so that I can say the most ionic. My answer option A sahi hai. Okay, the correct order of increasing ionic character. So let us talk about the beryllium, magnesium, calcium, and barium. So I just want to say, bigger the size, more is the ionic in nature. Yes. Now I just want to say calcium bromide, magnesium bromide, beryllium bromide. So ionic character is directly proportional to the cation. So barium 2 plus का size ज़्यादा है, इसका ionic character भी ज़्यादा होना चाहिए. Right? Understand? Now let's see here one more. Least melting point. Least melting point means it should be मोर कोवलेंट कौन है, मोर कोवलेंट कौन है, दैट इज द क्वेश्चन. सो क्वेश्चन आसान ही दिखता है, लेकिन उसमें असली चीज क्या है. सो लीस्ट मेल्टिंग पॉइंट, लेड क्लोराइड, टिन क्लोराइड, सोडियम क्लोराइड, AlCl3. लेड क्लोराइड लेड का +2 ऑक्सीडेशन स्टेट का है, टिन टेट्रा क्लोराइड +4 ऑक्सीडेशन स्टेट का है, सोडियम क्लोराइड +1 ऑक्सीडेशन स्टेट का, अल्यूमिनियम इज गोइंग टू बी +3 का. सो जिस आयन में चार्ज ज़्यादा है उस आयन का आप कोवलेंट नेचर ज़्यादा होना चाहिए. सो आई जस्ट वांट टू से हियर SN4+ supposed to be the correct answer. Size of the cation also, charge plays a crucial role, Anushka Rai. So that we can say which of the following is in the order of increasing covalent character. Definitely CCl4 का ही देगा नहीं. Okay, CCl4 है, so CCl4 is greater than covalent character BCl3, BeCl2, lithium chloride. So here it is a +1, +2, +3 and +4. So charge does matter here. Okay, Anushka? Wonderful. Yeah, Shubham, that's good. And if you have any doubts, please let us know. Make it. Yeah, it is C. And we'll do some more questions based on this. And this session contain both questions and concept. Get ready for that. Now let's see. So this is the overall picture about the Fajan rule. Covalent character inversely proportional to ionic character, it's a fundamental rule. And covalent character is inversely proportional to melting point. And covalent character is inversely proportional solubility in water, I would say. And covalent character is inversely proportional to the boiling point. Covalent character inversely proportional to size of cation, size of anion directly proportional, and charge on cation भी है. And covalent character is directly proportional size of anion and polarizing power. Yes, of course, covalent character generally say is directly proportional to polarization. So based on this, no wonder if you crack a question for the NEET examination, and also for any question from the P block B ho sakta. Okay, I just want to give you again the generalized picture here. सबसे बड़ा cation है, छोटा anion है, so it is more ionic, it is going to be more ionic, है ना. And also you are going to see small cation and big anion, it is going to be more covalent. Perfect. This is a perfect scenario, right? Make a snapshot of this, children. Now let's see. So lattice energy, what is this lattice energy? So it is सबसे headache topic है chemical bonding में. Don't feel it is not at all a headache topic. It is not at all a headache topic. We'll make it so simple and we'll discuss about this. Okay. Now lattice energy, whenever you see sodium plus in the gaseous state and Cl minus in the gaseous state and is giving rise to sodium chloride which is in the solid state plus energy. This energy that is called lattice energy. Are you getting or not? What is this lattice energy? The energy that is released when 1 mole of ionic solid is formed from its constituent gaseous ions is called as a lattice energy. And this lattice energy is designated by U. And the magnitude of the lattice energy is described by the Coulomb's law. So more the charge on the cation and the more the charge on the anion, so more is going to be the attraction forces between the cation and anion is going to be having more lattice energy. So the lattice energy is the key responsible factor that bind between two ions. So जिसमें लैटिस एनर्जी ज़्यादा है और दोनों का बीच में बॉन्ड स्ट्रेंथ भी बहुत स्ट्रांग होना चाहिए. Now that is given as lattice energy is directly proportional to the magnitude of the charge and inversely proportional to the distance between these two charges. है क्या ना? Right? And also you can see here the compounds of ions with higher charges have greater lattice energy than the compounds or ions with lower charges. So the lattice energy comes in the form of sodium fluoride is less than magnesium oxide and greater than and it is less than aluminum nitrate. कैसे होगा? इसका +1 -1 +2 -2 +3 and -3. So greater the magnitude of the charge, greater is going to be the lattice energy. That is a key point. Okay, that is the key point. And the properties of ionic compound. How do you calculate the lattice energy, my dear students? Before going for the properties of the ionic compounds, I just want to discuss that. How do you calculate lattice energy? You want me to explain Born-Haber cycle? So how many of you want me to explain Born-Haber cycle? Just give me a thumbs up in the chat box so that I can explain. Shubham, Anushka Rai, Ved, Sai Leela, Rohit Singh, waiting for the response. It is not a radio telecast session. It is going to be, yeah, Shubham, set thumbs up. It is a live interactive session where you can have a discussion between you and me. Okay, let's discuss. Let's discuss lattice energy by Born-Haber cycle. If required, I am ready to conduct a session 2 for chemical bonding also. Okay, don't worry if every topic is not completed in today's class. Lot many questions are there in today's class. Ready? How many of you do it? Okay. So let's see. Born-Haber cycle. This is the Born-Haber cycle. This Born-Haber cycle allows you to calculate the lattice energy. Lattice energy is the amount of energy that liberated when 1 mole of ionic solid is formed from its constituent gaseous ions. So, it is impossible to calculate lattice energy direct method, but we can calculate the lattice energy indirectly by using Born-Haber cycle. So, the Born-Haber cycle follows the Hess law of constant heat of summation. Hess law of constant heat of summation says heat of reaction is same whether the reaction takes place in a single step or in a multiple steps. Okay, let's talk about the combination of the single and multiple steps. So, sodium, which is actually a gas, combined with half chlorine, which is a gas, gives rise to sodium chloride, which is as a solid. So, how much amount of heat is released? That is called as a Q, heat of a reaction. You can say it is a heat of a reaction. Carefully you see Anushka Roy. So, this is a direct step. अब हम देखने वाला है indirect step में क्या चलना. So, sodium is going to be converted into, which is actually a solid beta, which is actually a solid. Okay, I just want to say it's a solid by which of its nature it is going to be converted into sodium in the gaseous state. That is process is called sublimation. Yeah, exam is very near, but why so fear if Suresh is there? Shubham, thank you very much for your concern, and that's the way every day you attend our classes. So, I am going to come up with very good things. This is what is called as sublimation process, and you can say this energy is called sublimation energy. ये energy इसका देना है endothermic process है. And I have chlorine, and I just want to get the chlorine in the gaseous state. This is called as a dissociation or atomization. So, the energy that is given for enthalpy of atomization, that is given as d by 2. Why d by 2? एक मोल के लिए d dissociation energy मान लो, इसमें आधा मोल के लिए d by 2 चाहिए. Are you getting or not? Now, Na plus is ready. Let us make it Na is ready. Let us make it Na plus होगा. That process is called as ionization. शुभम, so इसके लिए आपका चाहिए ionization energy, the amount of energy required to remove an electron from isolated gaseous neutral atom is called ionization energy. Now chlorine gas है ना, this is an atom, इसके लिए एक electron add करना चाहता हूँ. So for that electron affinity exothermic process होगा ताकि इसका Cl minus in the gaseous state होगा. Now Na plus in the gaseous state आपका तैयार है, Cl minus in the gaseous state तैयार है, दोनों मिलके आपका NaCl, the lattice is going to be formed. Okay, so this is called as lattice energy. So I just want to say the sum of this is equal to the sum of this, right? So I just want to say here the calculation part, dear children, Q is equal to the magnitude of plus S and plus IE plus D by 2 and minus EA minus U, lattice energy. Now anything will be given, the other thing is going to be, Suresh Kumar, one thing will be given, the other thing is going to be asked as far as a simple thermodynamic algebraic calculation. Any doubt, my dear children? Any doubt, my dear children? Wonderful. Want to see? Yeah, take a snapshot of this. Come on. Yeah, so come on, any doubts, please make it. Anushka Rai, thermodynamic session when? In this week, day after tomorrow. In this week, day after tomorrow. Fine. So you see the experience that is driven in your session. So you want to have this kind of sessions. You need to travel along, use traffic jams in this hot summer, but you can sit at your home and you can experience these great lectures from Infinity Land YouTube channel, right? So it is completely free of cost. You please attend our sessions and just please like our sessions, share with your friends, that's it. हम लोग बच्चों के लिए कुछ भला करना चाहता हूँ, सो भला करने का कोशिश कर रहा हूँ, सो अच्छा सोचो अच्छा होगा आपको, so that you believe in us and take a pen and paper and do the questions along with us and write the key points from us and you are going to be the best. You may feel that YouTube में क्या चलता है, so NEET निकलेगा नहीं, YouTube depend करना था, यार YouTube dependent students are there who are the toppers as well. So stay tuned and we'll do the best. Going back to properties of ionic compounds. Properties of ionic compounds. We have very good number of questions as well. So 200 slides I made it for you. Can you believe it? Arre. Properties of ionic compounds. Shall we? Or you want a short break? You want me to continue or you want a short break? Properties of ionic compounds. Anushka Rai? You want a short break? You want me to continue? So ये 2 घंटे का सेशन है, 1 घंटे बीच में एक 3-4 मिनट्स ब्रेक लेना चाहता हूँ आपके लिए. नो ब्रेक, ए शॉर्ट ब्रेक. ओके, 50-50. सो मैं ये प्रॉपर्टीज ऑफ आयनिक कंपाउंड करना चाहता हूँ, बाद में 5 मिनट ब्रेक देना है, ठीक है? सो नो वरीज, डोंट वरी, फील फ्री. We are here to share knowledge. Okay, we are here to give the best to the students. Okay, student को जैसा चाहिए वैसे देना चाहता हूँ. And get ready for the marathon sessions also. So 1 day total organic chemistry, morning 9 to evening 9. And 1 day physical chemistry, morning 9 to evening 9. Ready? And let's talk about the properties of ionic compounds and hardness and the brittleness. Okay, the ionic compounds are hard in nature and the brittle of the crystal is due to the movement of layers of crystals on other layer by application of extra pressure. So I just want to say here, they are having a hard and crystalline compounds with high melting point and boiling points. Fine, hard. And the melting point and boiling point of ionic compounds are very high. Why they are high? The cation and anion बीच में strong electrostatic forces रहते हैं. ये strong electrostatic forces break करना बहुत मुश्किल है. So we have to give a huge amount of energy. ठीक है? And solubility, ionic compounds are polar because of the presence of oppositely charged ions. So more they are going to be soluble in polar solvents and insoluble in non-polar solvent. The solubility depends on various factors. जहाँ पर हाइड्रेशन एनर्जी, जिस कंपाउंड का हाइड्रेशन एनर्जी इज ग्रेटर देन लैटिस एनर्जी, ताकि इसका solubility होगा soluble in water. If not, it is not. If hydration energy is less than lattice energy, it is going to be insoluble in water. It is a simple logic. It is a simple logic. Ionic bond and covalent bond. Ionic bond is strong bond as compared to the covalent bond. Right? Ionic bond is always strong as compared to the covalent bond. And also you can say electrical conductivity. So ionic compounds are bad conductors in the solid state and good conductors in the molten or fused state, and it is an excellent conductors in the aqueous state. So the conductivity does matter. Conductivity does matter. I just want to give you very good here. I wanted to give you very good thing, conductivity. Conductivity. It is related to electrochemistry as well. See, it is related to electrochemistry as well. So conductivity. Lithium plus sodium plus potassium plus rubidium plus and cesium plus in the molten state. In the molten state. And it is going to be greater and greater minded. When these are dissolved in the water, water molecules are going to be surround around it. So that more the hydration, it is going to be more is the larger in size and lesser is the conductivity. I just want to say lithium plus aqueous, sodium plus aqueous and potassium plus aqueous and rubidium plus aqueous and cesium plus aqueous. So it is going to be the reverse order. This reverse order is very important in the NEET examination. So you can directly get a question from the NEET examination based on this. Okay, this as well as this. Got it? Clear? Any doubt? सो आयोनिक मोबिलिटी और आयोनिक कंडक्टिविटी दोनों एक ही होता है. Yes. Now let's discuss the next point over here. Shubham, any doubt? Anushka Roy? So ionic reactions, the reactions participated by the ionic compounds are too fast. So reactions are too fast, they are instantaneous. Say an example, sodium chloride react with silver nitrate gives rise silver chloride white precipitate. Formation of this white precipitate takes place in a very small instant time. It is near about a nanosecond. And also space isomerism, ionic compounds are non-directional, so they do not show space isomerism or stereoisomerism. You are going to get a assertion reasoning type question or statement 1 and statement 2 type questions. So this is a very important point. Okay, before we enter in the covalent bond and other things, let us take a short break of 3 minutes or 4 minutes. You know, we'll take, because yeah, ready? So stay tuned. It will come. Yes, let's start. Ready? PBD, fast reaction. So let's come back. So, well, my dear students, thank you very much, and we'll discuss about the rest of the students. Welcome back to the session after a quick break. So these are things. So now a bit of questionnaire session. Anushka, fine. So here, is the formation of anions is given by. I want you to give the answer in the chat box. I want you to give the answer in the chat box. Lower value of ionization energy, anion form करने का ionization energy का इस्तेमाल करते हैं, नहीं इस्तेमाल करते हैं. Okay. Now I just want to say here, this is not the appropriate one. So I would say it is not correct one. And low value of electronegativity has no use here. Lower value of electron affinity. So higher value of electron affinity. So elements with high electron affinity has a great tendency to accept electrons. So this question comes, my answer is going to be 4. Agree? Wonderful. Let's talk about one more question. Which of the following is easily formed? Calcium chloride, Ca2 plus 2Cl minus, and calcium bromide, Ca2 plus Br2 minus, potassium chloride, K plus and Cl minus, potassium bromide, K plus and Br minus. So the ion with less charge on it can be easily formed as compared to the ion with more charge on it. Anushka, Shubham, come on. So the answer for this question is going to be potassium chloride nahi hai. It is going to be potassium bromide is the correct answer. 4. My answer is going to be 4 over here. Okay. And let's see number of electrons transferred from one aluminum atom during the bond formation of aluminum fluoride. Aluminum loses 3 electrons, gives rise aluminum 3 plus, and 3 fluorine atoms takes 3 electrons, gives rise 3F minus, so that it is going to get AlF3. So there are 3 electrons that are involved in this process, right? So let's see, the answer is going to be 3 over here. And the compound with highest melting point means it should be most ionic. It should be most ionic. So who is going to be the most ionic among the sodium chloride, sodium fluoride, and sodium chloride, sodium bromide, sodium iodide? Answer? You want to say D1? Sodium fluoride? Yes. Here you can see the answer is going to be 1. So always I said bigger cation, smaller anion is going to be more ionic, and vice versa. And a smaller cation and bigger anion is going to be more covalent. Okay? Understand? Clear? Now, among the following compounds, the one with the greatest ionic character, you only have to tell. Anushka, you only have to tell. So I discussed ample number of questions, expecting an answer from you guys. Now it is going to be, yes, जिसमें बड़ा size होगा, that is size does matter. So lithium plus small, sodium plus small, potassium plus small, rubidium plus small, and cesium plus. So cesium plus सबसे बड़ा वाला है. So that is the answer. Understand? Clear? And according to Fajan rule, the covalent nature of ionic compound is favored by, it is asked in AIMS 999. It was a previous AIMS question. So expecting an answer here. Large cation, small anion, large cation, large anion, small cation, large anion, small cation, small anion. मैं ज़्यादा बार बोल चुका हूँ, it is going to be more ionic. It is going to be more covalent. it is going to be more covalent. So you only have to decide the answer. So small cation, large anion, covalent nature का है ना? Yes. Answer is C. Got it? Yeah. Shubham, you are not participating in discussion, dear. I'm expecting answer. जल्दी. और एक क्वेश्चन देना और कॉन्सेप्ट बनना. क्वेश्चन और कॉन्सेप्ट. Okay. Even though crystal radii of both K plus and Ag plus are almost same, the melting point of AgCl is only 455. While the KCl is going 776. Why? Melting point ज़्यादा होने तो क्या मतलब है इसका? इसका ionic property भी ज़्यादा है. So more is the ionic character, more will be the melting point. So the answer for this question is going to be AgCl has more covalent than KCl due to the greater polarizing power of silver ion. Why silver ion has more polarizing power? Because silver ion has pseudo noble gas configuration. Pseudo noble gas configuration. Are you getting or not? Clear? Now you tell me answer. Order of covalent nature of aluminum halides AlF3, AlCl3, Lbr3, Li3. The best explanation according to Fajan rule is size of I minus increased, covalent nature increases. Answer 2. The polarizability of halide ions increases with increase in the size of, and hence the covalent nature also increases. Right? Now, the polarization is distortion of shape of anions by adjacently placed cation. Which of the following statement is correct? Participate in this question and answer discussion, my dear children. Okay. So the answer for this question is going to be maximum polarization is brought about by cation of high charge. So polarization is directly proportional to charge. Directly proportional to charge. Understand? Okay. So Anushka, Shubham, Suresh Kumar, you please participate in this kind of discussions here. Which of the following has high polarizing power? So polarizing power is directly proportional to the charge. Check the charge. किसका चार्ज ज़्यादा है? किसका चार्ज ज़्यादा है? Aluminum का चार्ज ज़्यादा है. So the answer for is going to be 2. Okay. And also maximum covalent character associated with the compound. Again covalent character. Covalent character is directly proportional to charge. So here sodium plus 1, magnesium plus 2, aluminum plus 3, aluminum plus 3. So these are not. And among aluminum chloride, aluminum iodide. So I minus is bigger than bromide ions is bigger than chloride ion is bigger than fluoride ion. So fluoride ion. So that iodide is bigger. So my answer for this question is going to be D. Okay. So it is going to be 4 or D. So every question, multiple layers of question I am just bringing you to guys and working on it. है ना? And we'll do it according to Fajan rule. The covalent bond is formed by, again, the same kind of question I have given. It is going to be the answer 3, small cation, large anion is the only option, and polarizability of the halides. Polarizability of halides. So I just want to say polarizability, polarizing power polarizing power is directly proportional to 1 by size of cation, of course, and polarizability of anion. Polarizability of anion is inverse directly proportional to size of the anion. Size of the anion. Are you getting or not? Clear? Anushka? So that polarizability is going to be F minus is less than, Cl minus is less than, Br minus is less than I minus. Are you getting or not? Clear? Hi Rishi Chandra. Good afternoon, beta. कहाँ है अभी फिलहाल? Rishi Chandra, how are you preparing for your NEET examination? And share your opinion, how you are preparing and how may I help you. So you can demand or request anything by using chat box so that we cater these things for the students' benefit. Okay? Shubham, yes. Shubham, where did you go? आप आंसर नहीं दे रहे. आप आंसर नहीं दे रहे. Okay. So the answer मिला F minus Cl minus Br minus I minus. Okay. Yamong. And I want to go into the next topic. Lunch. Oh, मैं lunch भी किया नहीं फिलहाल. Now done ना. So after this session I will take a lunch. After that one more session is there. Okay, come on. So let's discuss about among lithium chloride, rubidium chloride, beryllium chloride, magnesium chloride, the compounds of the greatest and the least ionic. So this is the typical model of the question that you are going to encounter in upcoming NEET examination. So I don't want to say the same question will come, but this is the model of the questions you are going to experience it. So here the ionic character order. So rubidium chloride is more ionic than lithium chloride. Okay, ये दोनों के बीच में. And beryllium chloride and magnesium chloride. Among them, magnesium chloride and beryllium chloride. So beryllium chloride is less ionic and more covalent. So it is the order. So this is the order. So it is more ionic and it is going to be more covalent. It is going to be more covalent. ठीक है? है ना? So your answer is RBCl and BCl2. So that RBCl and BCl. Did I deny your answer? Shubham, यार लगे रहो, चलता बेटा. God bless you. So when I discuss the questions, okay, you never get the question is the substandard. Don't feel that. The NEET examination question paper do not ask you how depth your subject knowledge is. Rather, it is going to ask you what is your understanding ability and what is the application ability, how to handle that question. So these are the things you have to take care. And of course, when you have a question based on Fajan rule and based on properties of ionic compounds and factors favorable in ionic compounds are important. Factors favoring in ionic compounds is very, very important. Okay. So covalent bond, mutual sharing of electrons between two elements is called a covalent bond. It could be hydrogen, hydrogen fluoride, chlorine. You can have basic examples of homoatomic covalent molecule and heteroatomic covalent molecule and polyatomic covalent molecule, polar and non-polar covalent molecules kind of things. Okay, I don't want to discuss much more details about this. Rather, I want to go ahead where explanation is required. Okay, if you want to have any discussion in any part of this context, you please let us know, so that we can have incomplete octet. So we all know what is octet. The elements, the compounds in which the central atom has 8 electrons in the outermost shell are called octet compounds. Okay, this is given by Koshel and Lewis, and there are some compounds where octet is not followed, so that is incomplete octet, hypervalent compounds or hypooctet compounds. In this hypervalent compounds and hyperoctet compounds, you can say electron deficient compounds will be there: beryllium chloride, BF3, boron trifluoride, BCl3 and AlCl3 kind of compounds will come. Okay, and also expanded octet compounds. In the expanded octet compounds, you are going to get hypervalent compounds. So, in the hypervalent compounds, where you can see period 3 elements like you can say PCl5, SF6, IF7 kind of things, Xe compounds also, xenon difluoride kind of compounds, where the compounds in which the central atom has more than 8 electrons in its outermost shell are called hypervalent compounds, my dear students. So, in the NEET examination, you will be asked which of the following is following octet rule, or electron deficient, or octet less, or incomplete octet, or super octet, or expanded octet. And we can see odd electron species also. We can see odd electron species also. Any doubt? Please let us know, so that I am going to talk about odd electron species. How can I say that? Now, let us talk about odd electron species. So, that is very, very important. Some molecules contain an odd electron on the electrons, like nitric oxide, nitrogen dioxide, chlorine dioxide. So, sir, how do I know nitric oxide? So, you can see nitric oxide na nitrogen valency कितना outer shell में 5 electrons होना है, ऑक्सीजन का कितना 6 electrons होना है, दोनों मिलकर आपको 11 electrons मिल रहा है ना. ऑड इलेक्ट्रॉन ऑलवेज इलेक्ट्रॉन जोड़ी जोड़ी रहता है ना, ये अकेले रहते हैं. ओके, सो to draw this kind of things, we need a resonating structures. So let's talk about resonating structures for that. Okay, so let's talk about the formal charge. Formal charge is denoted by Q and QF. And what is a formal charge? The formal charge is the charge acquired on an atom in its possible, probable, proposed Lewis structure, जिसमें formal charge आता है. So, use of formal charge. So, when you talk about the resonating structures or possible Lewis structures, the structure is absolutely imaginary structure. So, that imaginary structure may be true or may be wrong. So, for that we need to calculate the charge on every atom. So, electron देने वाला कौन है, electron लेने वाला कौन है, ये decide करने का ये formal charge पकड़ के आप कर सकते हैं. That is given as Na minus Nm. In that Na minus Nm आता है NLP lone pair plus upon number of half into number of bond pairs. Understand? Half into number of bond pairs is very important. Okay. Just a minute. Yes, it is. So this is the formula can help you. This is the formula can help you. Na is the number of valence electrons in the free atom, and Nm is the number of valence electrons belonging to the atom, the molecule, and Nlp is the number of lone pairs of electrons in the lone pairs, and Bp is the number of electrons in the bond pairs. समझ में आ रहा है क्या? And also, which of the following has an odd electron? You only have to tell me. You only have to tell me. Answer? Yeah, it is going to be Cl with chlorine trioxide. Okay, and also which of the following molecules obey octet rule? Any boron compounds and beryllium compounds do not accept octet rule. Okay, here this will not, and this will not, and this will, and this will not, because the period 3 is going to expand it octet. Understand? And answer is going to be 3 over here. So Shubham and Anushka, be interactive. Now here the covalent bond and the compounds properties of covalent bond. Okay, I just want to discuss some overall image of this covalent and ionic relative properties. Okay, now we can see under normal conditions and temperature and pressure, covalent substances exist as gases or volatile liquids. Okay, that's it true. Sometimes it is going to be so hot like diamond, graphite, सिलिकॉन कार्बाइड. जब मॉलिक्यूल का पॉलीमर बनता है ना, इसका फिजिकल स्टेट अलग होता है. एंड मेल्टिंग पॉइंट एंड बॉइलिंग पॉइंट, जिसमें in covalent substances intermolecular forces are van der Waals forces of attractions, so they have very low melting point and boiling point. Okay, and so you can see physical state, and yeah, we discussed this. And solubility, generally the covalent substances are insoluble in polar and soluble in non-polar like organic solvents. And also isomerism, yes, the covalent bond is directional, therefore exhibit isomerism, space isomerism. That's very important. Here you are going to see assertion reasoning type questions and statement 1 and statement 2 questions. Okay, statement 1 and statement 2 questions, understand? And you can say coordinate bond, it is a special type of covalent linkage, coordinate covalent bond, and it is also called as a dative bond. Everything we are discussing, don't worry my dear students, we are going to have part 2 version of the chemical bonding as well. Okay, so where an atom is going to dative bond is a special type of covalent bond where one atom is going to contribute the pair of electron and both the atoms are going to share. So there you are going to have a donor atom and it is going to have a acceptor atom. So the donor atom should have at least one lone pair electron and the acceptor atom should have at least one vacant orbital with it. Okay, so this is the same version we are going to discuss in the Lewis acid base theories. Yes, both are same. So the donor one is called as Lewis base and the acceptor one is called as Lewis acid. Understand? And NH3H2O, SCl are going to be the donors and then acceptors are the ions like H plus or BF3 or AlCl3. समझ में आ रहा है क्या? Anything? Do you find covalent bond? How do you find covalent bond? Everything can be seen over here, right? It is very, very important thing, my dear children. And you can see NH3 इसका एक lone pair of electron इसका दे देते हैं, so that a arrow mark दिखता है ना, that is called as a dative bond. and similarly H3O plus बनने के वक्त में lone pair of electron present on the water ये H plus को देने के बाद hydronium ion बन गया. And also you can see carbon monoxide molecule, HNO3 molecule, and copper complex. Okay, you can see I3 minus, and everywhere you can see the coordinate covalent bond or dative bond. My dear students, अगर कुछ डाउट है ना तो पूछना बेटा. Right? Shubham, come on. Now, in this O3, SO2, SO3 में मी है dative bonds, and also the properties of the coordinate covalent compound intermediate of ionic and covalent compounds. Comparison of ionic compounds with the covalent compounds along with the coordinate covalent compounds is given here. Let's see, it is going to be super important. एंड कोऑर्डिनेट कोवलेंट बॉन्ड का जो प्रॉपर्टीज आता है ना ये दोनों का बीच में होगा. एंड यू कैन सी हियर डियर चिल्ड्रन बाइंडिंग फोर्स. सो बिटवीन द आयोनिक द बाइंडिंग फोर्स इज अ कोलुम्बिक फोर्स, and between the atoms the covalent bond is the van der Waals force among the molecules, and the coordinate covalent bond the bonding is going to be in between होगा. ओके इसका बीच में तो मेल्टिंग पॉइंट बॉइलिंग पॉइंट आयनिक कंपाउंड का ज़्यादा होता है शुभम, एंड वेरी लेस फॉर द कोवलेंट बॉन्ड, एंड कोऑर्डिनेट कोवलेंट बॉन्ड का प्रॉपर्टी ये दोनों का बीच में होगा. एंड यू कैन सी कंडीशन द कंडक्टर्स, आई जस्ट वांट टू से दे आर वेरी गुड कंडक्टर्स इन aqueous state and they are bad conductors, and they are usually not conducting but they may conduct better than covalent compounds. So Shubham, and solubility है, this is very important. कहाँ है slide? हाँ, this is going to be a solubility. Yes, talking about the solubility. Solubility in the polar solvents for ionic compounds का काफ़ी ज़्यादा होगा, and it is going to be less for covalent compounds, and it is going to be in between. And you can see solubility in non-polar solvents, ionic compounds का ज़्यादा होगा, and it is highly soluble in non-polar solvents like organic solvents, and coordinate covalent compound solubility ये दोनों का बीच में होगा. And you can see physical state, of course ionic compounds generally they are solids, and generally they are gaseous or liquids, and they can be solid or they can be liquid or they can be a gas. Understand? Any doubt? And you take a snapshot everybody. Okay, let's discuss more things about here. Correct order of decreasing polarizability. Again questions. This is Cl, no? Cl minus. Okay, decreasing order, it is going to be I minus Cl minus, okay, I minus Br minus Cl minus. Size does matter. Understand? That's good. And one more, which has the highest polarizing power? You tell me which has the highest polarizing power. You want to say C? How it is possible? How it is possible? Shubham? Polarizing power is directly proportional to the charge on the cation. है ना? शुभम, चार्ज जिस कैटआयन में चार्ज ज्यादा है, लास्ट वन है आंसर सी है ना। अभी ये क्वेश्चन का आंसर कितना देना मैं, जल्दी बताओ। आंसर, वेटिंग फॉर योर आंसर। अल्यूमिनियम 3+, अल्यूमिनियम 3+, ठीक है। यस, यू आर करेक्ट। नाउ valency shell electron pair repulsion theory. So this is the theory where I wanted to say central atom, a molecule का shape decide करने का VSEPR theory इस्तेमाल किया। Okay, in this VSEPR theory, a molecule, a polyvalent molecule का a central atom है। So the shape of the molecule is based on the number of electron pairs present in the central atom. Okay, in this central atom, electrons are always present in the pair, जोड़ी जोड़ी रहता है। So these pairs are two types, lone pair of electron and bond pair of electron. And lone pair जो है ये ज़्यादा space occupy करते हैं and repulsion भी ज़्यादा देते हैं। जो bond pairs हैं, they are going to be occupied by the bonded central atom and it has a less repulsion and will have more stability. Of course, they have the less repulsion. Among the repulsion, among the lone pairs and bond pairs, lone pair repulsion on lone pair is greater than, lone pair repulsion on bond pair is greater than, bond pair repulsion on bond pair. ये order का हिसाब से काफ़ी बार नीट एग्जामिनेशन में क्वेश्चन आने का संभावना है। सो these electron pairs are arranged in such a way that repulsions among them are minimized and they are going to have a proper shape. So the shapes generally it is given as, if a lone two pairs are there, it is going to be a linear. If three pairs are there, it is going to be trigonal planar. Let us say A is a central atom and B is a bonded atom. So that how can I say this is a linear, you can say A and B irregular geometry, it is a linear, बीच में 180 आना संभावना है। Are you getting or not? Clear? And you can see trigonal planar. In this trigonal planar I want to show you A and here B and it is going to be trigonal planar and बीच में 120 degrees angle आना है. So that is planar triangular. Okay, hi YouTuber, it is octahedron कैसे? And it is a tetrahedron. You can see it is A and it is going to be B and B, it is a tetrahedral geometry and it is going to be 109 degrees 28 minutes. So that is a tetrahedral geometry. समझ में आ रहा है क्या बेटा? Okay, following it, following the table, and also you can see trigonal bipyramidal. I just want to change the color. एक बाहर लिखना चाहता हूँ, एक अंदर लिखना चाहता हूँ. So it is going to be a trigonal bipyramidal में a triangular geometry है, उसमें एक A and it is going to be B, a triangular geometry में B and उसमें आता है आपका B. So you have a triangular bipyramidal geometry, उसमें ये axial bond है, ये equatorial bond है. Equatorial bond is shorter and stronger and axial bonds are going to be longer and weaker. And it is going to be octahedron. Last one is going to be octahedron. This is going to be octahedral geometry A. Okay. It is going to be B. It is an octahedral geometry B like this, like this, like this. It is going to be octahedron. the bond angles that you can see, you are going to get 90 and you're going to get 180. Okay, so how many 90 degrees are there? That is the question in the NEET examination. How many 90 degrees angles are there? That kind of questions are very, very important. If there is no lone pairs of electrons, these are the regular geometries that you can see. And we are going to see the details about this. Okay, molecules with no lone pairs of central atom like Ab2 beryllium chloride is going to have a linear shape, my dear students, that you have Ab2 model, and you have Ab3, that is going to be boron trifluoride. इसका structure boron trifluoride ऐसे आता है. Are you getting on or clear? So see the structures. If you have any doubt, Shubham and Anushka Rai, Rishi, and who is somebody is there right now. Okay, YouTuber also is there in the class. Okay, wonderful, wonderful to see. Hundreds of students are there. So that is the same. That is the same pitch I want to see for this long marathon sessions also. So it is a trial run, you can say. And you see Ab4, this is an example of methane. It is a tetrahedral. CH4 is going to be a tetrahedral with a bond angle of 109 degrees and 28 minutes. So this 109 degrees 28 minutes is also called as tetrahedral angle. Okay, and also Ab5, phosphorus pentachloride. And this phosphorus pentachloride in the gaseous state exists as a trigonal bipyramidal geometry. So I just want to say, as the time comes now, PCl5, okay, exists in as a gaseous state and the vapor state as PCl5. It is undergoing sp3d hybridization. How PCl5 exists in the solid state? Okay, it exists as a dimeric state, that is going to be PCl4 plus and PCl6 minus. Okay, that is ionic in nature, mind it. इसमें आपका हाइब्रिडेशन क्या, इसमें आपका हाइब्रिडेशन क्या होगा? हाँ, yes it is sp3d होगा, इसका sp3 होगा, इसमें sp3d2 होगा. समझ में आ रही क्या बेटा? जे नीट एग्जामिनेशन में एक काफ़ी इंटरेस्टिंग पॉइंट का वजह से क्वेश्चंस आने का ज़्यादा संभावना भी है. So mind it, we are giving you very good amount of content. Everybody please take a note like this important things, and as days goes on we are going to provide some more important things. And let us talk about Ab6 sulfur hexafluoride. And Shubham, इसका shape and geometry क्या होगा? Shape and geometry क्या होगा? सुरेश कुमार, it is octahedron. It is an octahedron, है कि ना? Yes, there is no odd electron. There is no odd electron. There is no odd electron. ठीक है? Right. Now, there are certain things I just want to give you. NCl3, नाइट्रोजन का टोटल वैलेंस इलेक्ट्रॉन्स एंड क्लोरीन टोटल वैलेंस इलेक्ट्रॉन्स. इसमें यू कैन हैव 5 वैलेंस इलेक्ट्रॉन्स. इसमें ओके 7 into 3. Okay, so 21 plus 5 is equal to 26 valence electrons are there. So required only 3 sigma bonds and 1 lone pair is there. This is the lone pair of electron. So you are going to have sp3 hybridization. So total steric number 4 होगा. So इसका वजह से sp3 होगा. Shape is going to be trigonal pyramidal. Like that हर structure का आप खुद analysis पकड़ना ज़्यादा important है. Suresh and YouTuber, come on, and Shubham, Rishi Chandra, and Anushka Roy and Tribeni Roy, who are else there in the online. Okay, come on, let's talk about ORIC example BBR3. So total here 7 into 3 plus boron का valency 3 का है. So you're going to get 24 electron deficient, so that you have sp2 hybridization. The shape of the molecule is going to be trigonal planar triangular, and the bond angle here perfectly I can say it is going to be 120. So why I am confidently telling it is 120, because there is no lone pair. जब तक lone pair नहीं है, आपका जो bond angle देख रहे हैं ना, ये standard value रहना है. And also, और तीसरा है SiCl4, you are going to get silicon valencies 4. कैसे पता चलेगा? ग्रुप 14 का है. Carbon, silicon, germanium, tin, lead. Okay, all have 4 electrons in the outermost configuration, my dear children. And say chlorine, you have 7 electrons or 4 atoms is going to be 32 electrons. उसमें हमको चाहिए 4 sigma bonds हैं. And it should be sp3 hybridization, and it is going to be tetrahedral in geometry. Okay, you joined in Himat Nagar branch, congratulations. Okay, let us follow the lesson better. Let us follow the lesson. Okay, so no need to just spam a lot many more times, right? So let's see some more examples. We'll see some more examples. We'll see. Shubham, Suresh Kumar, come on, let's see here, and you can see, yeah, ICl4 total valence electrons 32, and it is going to be tetrahedral, and SF6 total valence electrons 48. It is going to be octahedral or square bipyramidal, you can say, but octahedron is the appropriate word, you can say. Octahedron is the appropriate word. Understand? Clear? And BEF2, we discussed it. The first, it is going to be 16 electrons total, and it is going to be sp hybridized, and it is linear. And I want to give you some weird examples over here. You can see ClF3. You are going to see chlorine, it has 7 valence electrons. Okay, you can see chlorine, it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So the lone pair of electrons are there, and fluorine is going to form a bond over here. Fluorine, you are going to say a bond over here. Fluorine over here, you want to say a bond over here. You can say T shape. You are going to say T shape. Now, can you say what is the angle here? What is the angle here? The question, is it exactly 90 or less than 90? Option is yours. Is it exactly 90 or less than 90? It is going to be little less than 90 degrees. Why so? Because there is a lone pair repulsion. There is a lone pair bond pair repulsion. Understand? That's very important. So everybody knows this ClF3 is a T shape, but and the repulsion के बारे में क्वेश्चन आने का संभावना है. A bond angle का बीच में क्वेश्चन आने का संभावना है. Understand? And let's see one more, PF5. The same trigonal bipyramidal ClFy का है, same just like ClF5. Understand? Just like ClF5, right? And उसमें I want to say this is a X and this is a Y. So bond length, I want to say X is less than Y. That is very, very important for NEET examination. So here very seriously NEET examination preparation is going on. So I expect every student to participate in this. So I am not simply disclosing this structures. I am disclosing granular level where the question can come. And you can see one more, yes, XeF4, total valence electrons 36. So it is going to be AB4E2 model. There are 2 lone pairs of electrons and 4 bond pairs of electrons with the central atom. So that these are the probable structures. Yes, these are the probable structures. I said probable. कौन सा probable structure ज़्यादा important है? You tell me first A, B, C. Which is the most probable structure? Which is the most probable structure? Expecting? Dear children, expecting the answer. Which is the most probable structure? Why? Because it is, my answer is going to be here, it is A is most probable. Why? Because the lone pair of electrons are maintaining the maximum distance. इस बीच में repulsions कम से कम होगा. As the electron lone pair is maintaining the far distance away apart, so that they have the least possible repulsion, is going to the most probable structure. That is about the VSEPR theory. Here XeF2, it is going to be A, B, 2, E3, steric number 5. It is going to be trigonal bipyramidal. You can see X, E, okay, it will be a lone pair of electron over here. Whenever lone pairs are there, it is kept in the equatorial positions minded, and it is going to be F, and it is going to be F. It is a linear in geometry, and lone pairs maintain 120 degrees and bond pairs maintain 180 degrees. That's very important. So that's an important point. The angle between the bond pair and lone pair is 90, and the angle between the lone pair and lone pair is 120, and the angle between the bond pair and bond pair is going to be 180. Are you getting or not? Next, PF2BR3. So this is a little high end question. You can say it is HOTS, higher order thinking questions. ये भी होना चाहिए ना. So it is going to be trigonal bipyramidal, but the most electronegative elements is going to be fluorine over here. You can see fluorine over here. So the fluorines equatorial positions में आना चाहिए. जब equatorial positions में है ना, इसका lone pairs का noise ज़्यादा होता है. So they are going to have, the more electronegative is going to stretch the bond more lengthy, so that it is going to be longer bond, so that it is kept in the equatorial positions. That is the logic. So electronegativity का हिसाब से ये fluorine equatorial में डाला. Okay, now PO for 3 minus phosphate ion. So you are going to see the various resonating structures, and a resonating structures का phosphate ion का you are going to see this is a tetrahedral, regular tetrahedral. Okay, and also see NO2 minus, it is going to be a bent shape. A day2 bond is there, a day2 bond is there, sp2 hybridized, and the previous one is sp3 hybridized. Here it is sp3d hybridized. You are going to get again sp3d hybridized, my dear children, and a lot many things are we are going to discuss here. Let us say nitrite ion sp2, and it is an angular. Okay, and let us talk about the carbonate ion. Carbonate ion, carbon undergo sp2 hybridization. It is going to be trigonal planar structure, and it will have the various resonating structures like this. So if these resonating structures are not that clear, I can draw these resonating structures, and you can calculate the formal charges as well. And you can see this oxygen carries 2 lone pairs, this oxygen carries 3 lone pairs, and this oxygen carries 3 lone pairs. And it is going to see the other resonating structure like this. Mind it, my dear children, while writing resonating structures, you need to understand the total number of electron pairs should be same and the position of the atoms should not be changed. Okay, total number of electron pairs should be same. इसमें जितना लोन पेयर है इतना बॉन्ड पेयर है उसमें भी ऐसे होना चाहिए. Okay, and the energy of this resonating structure should be nearly same. Okay, you're going to see, and it is going to be like this, and it is going to be like this, and it is going to be like this. Okay, and the total number of electron pairs in every structure should be same. उसमें लोन पेयर कितना, बॉन्ड पेयर कितना, उसमें लोन पेयर कितना, बॉन्ड पेयर कितना. सो उसमें लोन पेयर टोटल नंबर ना 1 2 3 4 5 6 7 8 8 लोन पेयर है इसमें. देखो 8 लोन पेयर एंड 4 बॉन्ड पेयर इसमें देखो. And charge is going to be 2 units minus 2 charge. Here lone pair 1 2 3 4 5 6 7 8 lone pair, 8 lone pair and 4 bond pair and minus 2 charge. यहाँ पर भी 1 2 3 4 5 6 7 8 lone pair and 4 bond pair and minus 2 charge. So the position of the atom should not be changed, the total number of electron pairs should be same, but the position of the electron pairs can be changed. है ना? That's good. So you can calculate the formal charge as well, and it is given as a bond order is going to be 3 by 2. That we'll discuss in the upcoming sessions, and you can see the BRF4 minus is going to be sp3 and is going to be tetrahedral. And these are all very important. Total valence electron ClO3 minus is going to be here 26 and sp3, and it is due to one pair of electron, one lone pair is there, therefore it is going to be pyramidal in shape. So carefully you have to work on each and everything in the last moment of the NEET examination. This is what you need to do. Anyways, we had a great swell in today's class. इससे एक्सटेंशन है, I want to discuss MOT and hybridization in the next class. No doubt about this. Students acquired a very important points like this, and we are doing the best from our side. So my dear students, we are done for today's class. We had a long session today, and again we'll meet with more stuff in the upcoming session. The day after tomorrow I come up with thermodynamics, we will discuss, and hydrocarbon part 3b hai, chemical bonding part 2b hai. So get ready, we'll meet with more stuff. And signing off, Suresh, Faculty of Chemistry from Infinity Lens Studio. Stay tuned. Thank you very much. See you. Bye bye.